In previous class, we have discussed about Thevenins theorem, and now we will discuss about how to solve the network by using Thevenins theorem. Let us consider the network is given as a 30 volt source is there, then it is connected with a 12 ohm and 6 ohm resistor, and the problem is that we have to find out the VTH and RTH, means Thevenin equivalent source as Thevenin equivalent about these two nodes A and B. In that case, what we have to do, we have to remove the load resistance or load voltage, whatever will be the situation will be there. We have to remove the element connected in between these two nodes A and B, and in that case what we have to do, we have removed the element A and B. Now what is VTH? In the Thevenin's theorem, we have to replace the whole network by a single voltage source and single resistance RTH. And let us consider this one is the VAB. VAB is what? VAB is VOC, or it is also known as VTH. For to calculate the VTH is what we have to measure the open circuit voltage across these two terminal, and for that reason, what we can do, we can place a voltmeter at these 2 points, and whatever voltage is will be readed by the voltmeter, that will be the open circuit voltage. In numerical way, what we can do, this one is the 30 volt source and this one is 12 ohm resistance, 6 ohm resistance. This part is what? Open circuited means there will be no current flow through this line, means current flowing through this line will be 0 ampere. So 0 ampere. So we can here we can apply mesh analysis, and we can measure the current flowing through this 6 ohm resistance. And if 0 ampere current is flowing through this point, means the whatever will be the voltage across these 2 points, that will be the voltage across AB, means VTH, because there is no any voltage drop across the 4 ohm resistor, because voltage drop can be calculated by V into I, and here current is 0 ampere. So it will be that will be the same terminal, because there is no voltage drop at this point. Because of that, this voltage across this AB will be the means this point will be same. Okay, so how what will be the voltage across these 2 points? Means that will be the 6 into, if we are considering this one is the current I, by mesh analysis we can find like that. Means I will be 30 upon 12 plus 6, means 30 by 18. That will be the current flowing through this point. Either you can apply voltage division rule here. If you want to estimate the voltage across at these 2 points, means if we are to consider this one is the R1 and this one as R2, in that case what will be the situation? The voltage across these VAB will be equal to, this one is what? R1, and this one is what? R2, and so resistance voltage across at these 2 points will be V into R2 upon R1 plus R2, and here V is what? 30, and R2 is what? 6, and R1 plus R2 means 6 plus 2. So whatever result we are getting, that one will be the VAB. Okay, because there is no current flowing through this point, that's why the whatever voltage we are getting here, that will be the open circuit voltage. Okay, and if we are having 10 volt of VTH values, now we have to estimate the RTH value. RTH value means how we can measure? We have to replace the all the sources by their internal resistance. Current source open circuited and voltage source short circuited, but here in this network we are having only one source, that one is the voltage source. That's why that will be short circuited. Previously it was this was the position of voltage source, now it is short circuited. And if you want to estimate the RTH values, means RTH ROC, this is nothing but ROC or ROC or RAB. Okay, so what will be the RAB value? And these 12 ohm and 6 ohm are in parallel, means the 12 ohm and 6 ohm are in parallel, and result will be in series with 4 ohm resistor. So how we can calculate the parallel, mean 12 into 6 by 12 plus 6. So that will resultant will be in series with 4 ohm. So RTH values we are getting here 8 ohm. Okay, likewise you can calculate the RTH value. So what will be the result? The final Thevenin equivalent network will be VTH 10 volt and RTH 8 ohm, and now again we have to insert the load resistance. Here load resistance was 2 ohm, that's why we have inserted the load resistance. And if anyone want to if in question if it is mentioned that what will be the Vx value, in that case again you can apply the voltage division rule here. V into R2 upon R1 plus R2, where means V voltage is what, 10 volt, 10 into 2 upon 8 plus 2, that will be the 2 volt. Okay, okay. Now in some cases it may become tedious to find RTH by reducing the resistive network with a sources deactivated. Consider the following: this one is the network, and if the this path means A to B path is what, ISS, means it is a short circuited. In that case how you can calculate? Yeah, means RTH will be VTH upon ISS. Okay, if we will apply KVL here, in that case it will be VTH upon ISS. So in that type of network what you can do, for this circuit, same circuit we have used, in that case the task in that case if it is mentioned that we have to find out the ISS. Okay, so in that case what we have to do, again we have to remove the path, and we have to find out the VTH and RTH value, and then we can find out the RTH will be equal to VTH upon ISS. Means this one same network was there, so VTH value is what, 10 volt, and RTH value is what, 4 ohm, and this resistance is what, again 4 ohm, and this path will be ISS. So how you can calculate ISS? ISS will be ISS will be ISS will be VTH upon RTH, but now the overall resistance will be 4 plus 4, so 10 by 8. So overall resistance will be, now RTH value will change 10. Okay, now this one is the another circuit in which voltage source and current sources are there, and for this network you have to find out the you have to find out the Thevenin equivalent network. So here this point is A and B, and the objective is that we have to find out the Thevenin equivalent network across these two nodes A and B. So for that what we have to do, to find out the Thevenin equivalent network, we have to find out the VTH means open circuit voltage and RTH means open circuit resistance. So for that reason what we have to do, we have to replace we have to remove load RL or loads, we have to remove the load, and whatever the voltage is readed by this at this 2 point by voltmeter, that will be the open circuit voltage. So if we have removed this path, in that case by applying mesh analysis or KVL, we can calculate the drop across these two, this resistance 10 ohm and this resistance 20 ohm. If we will apply KVL in this loop, so whatever will be the drop, voltage drop, that will be the VAB, that will be the VAB or open circuit voltage. Okay, and if this one is the open circuit, A and B is open circuited na, so current will be here 0 ampere, so this 1.5 ampere current will flow through this path only. Okay, so and we have to apply the voltage, you can apply the voltage division rule here. voltage division rule you can apply here, and by doing so you can calculate the voltage drop across this 10 ohm and 20 ohm resistor. If you got this voltage drop, that will be the, like here, 31 volt. So here what has been done, this 1.5 ampere current source is flowing through in this loop only. So 1.5 into 10, that will be the total voltage drop across this resistance. And by applying voltage division rule, means v into, if this one is r1, this one is r2, v into r2 upon r1 plus r2, means voltage was 20, and this resistance was 20 upon 20 plus 5. Likewise, you can calculate the VTH value, means it is coming 31 volt. So if you want to measure the RTH value, in that case what you have to do, you have to replace the all the sources by their internal resistance. In case of ideal current source, it would be open circuited, means infinity resistance is there, so that's why it is open circuited. And in case of ideal voltage source, that will be short circuited. So whatever the resistance will be measured by ohm meter, that will be the final RTH value, or open circuit resistance. In this case, 5 ohm and 20 ohm, those are in parallel. So R1 into R2 upon R1 plus R2. Likewise, you can solve the network. That will be that equivalent of this network will be in series with 10 ohm. So if we will add these values with 10 ohm, it will give the RTH value 14 ohm. Okay, so whole network can be replaced by a single voltage source VTH and a single resistance RTH. Okay, now we are adding the 17 ohm or RL. And if anyone want to know the what will be the VAB value, in that case again you can apply the voltage division rule, 31 into 17 upon 17 plus 14, that result will come 17 volt. Okay, likewise you can calculate the likewise you can solve the other types of network. So we will discuss in next class what will be the Norton's theorem and how you can solve the network. Okay, and also we will discuss this problem in next class. Thank you.